Hi there. Welcome to the Getting Started with the Code for ConceptGraphs tutorial video. I have a fresh install of Ubuntu here, and I'm going to be doing the installation and setup for ConceptGraphs, and then I'll make a map for a dataset, and that way this will work as a reference for that whole process, and hopefully help people get started easier with the code. So let's jump right in. If you don't know what ConceptGraphs is a mapping system that gets you the power of multimodal foundation models into a 3D map that robots can use. So I'm not going to go into the details at all in this video. There's another video I'll link to in the description for that. But in short, ConceptGraphs is a mapping system that builds a 3D scene graph given an input stream of RGB plus depth images with poses. And so, yeah, you want to go, if you Google ConceptGraphs, you'll find this website where you have links to the paper, code, and video explainer. If you want to know more about the method, just check out this website. And so we're going to go over to the code, where we have our README file for ConceptGraphs. So we want to go over to the Ali dev branch because this is where the refactored code is. We've made a lot of updates since the original release last year. And yeah, all you need to know is a little bit of Python and you should be fine in terms of prerequisites. So anyway, I'm just going to get started. I'm going to start with the data set actually, because that takes a little bit of time. So I'm going to open a terminal here and zoom in. I'm going to download the data set and then I can talk about the rest of the setup while the data set is downloading. So I'm going to make a folder called local data. You know what? I'll name it something different because I just want to make it so that I'm going to pretend to be a new person downloading. So I'm going to call it my local data because that won't be hard coded anywhere accidentally. Okay, and in here, I'm just going to use this download command for downloading the Replica dataset. The Replica dataset is a dataset of a bunch of indoor rooms. This is what it looks like. It's by Meta. And we're going to use that for our scans. And so this will take some time to download. In the meantime, we can start setting up the rest of our ConceptGraphs environment. So I recommend you use Conda for this. So I'm going to make a new terminal. Okay. Download. Cool. So we want to make a new Conda Python environment. If you don't know what Conda is, it's a package manager. You can go to their website and download it. And yeah, just again, a reminder, make sure you switch to the Ali dev branch where the refactored code is. So we're going to make a new Conda environment. Let's do that here. Press Y. And this basically makes an isolated Python environment so that if you have other packages at different versions for your other projects, it won't conflict with anything. So, and then you press Conda activate and you can see that over here base changes to ConceptGraph, which means we're using the ConceptGraphs Conda environment. So yeah, it's 3.10, great. All right, and now we just want to follow these commands. So we're installing PyTorch and CUDA and that sort of thing. So just you can pretty much blindly copy and paste these commands into your terminal. You might get some errors. So PyTorch and CUDA are not the most stable, and there you might have some trial and error involved to figure out which version of PyTorch and CUDA work for your system. Okay, so this might take some time, so I'll probably use the magic of video editing to fast forward over this. Oh, okay, we're back. And yep. PyTorch takes a while to download sometimes. So yeah, that might take a bit. In the meantime, we can also clone the repo. So I'm going to use HTTP, and I have VSCode. I recommend you use VSCode or PyCharm or whatever you want, really. So we're going to clone a Git repository. Actually, I'm going to do that in another terminal because I want to make a folder for that. Hope that this doesn't get too cluttered. So I'm just going to my code. And I'm going to git clone ConceptGraphs over here. Great. So now in VSCode, I can just open folder and go to ConceptGraphs. Say, yes, I trust the authors. Cool. So I'm going to zoom in a bunch here. That should be enough. Okay, I'm going to close VSCode for a moment. Yeah, PyTorch is still downloading. That takes a while. Okay, sweet. So that command is done. Let's just move on to the next one. Right. It's PyTorch before. Okay, so now we're going to do the FAISS library. It's used to match objects to each other. Okay, so that's done. For PyTorch 3D, we usually get some conflict. So this is the specific version of PyTorch 3D that will work. So install that. And you want CUDA toolkit, and CUDA toolkit dev just has more stuff, works better. Great, so our dataset has finished downloading. So we're just going to unzip it. Great. And yeah, there's some conflicts, just that's what Conda is for, just handle that. Yeah. Wow, I wonder if there's a quiet version of the unzip command. Maybe I should update the README. Oh yeah, another thing. So if you want to contribute to ConceptGraphs, please go ahead. The code is a little bit messy and complicated, but honestly, it's not that bad. And I'm actively maintaining the repository for the time being, so I'll be happy to help you use it or make a contribution. If there's something wrong, you can open up an issue, and I'll be looking at those as well. So, okay. Okay, great. So our CUDA toolkit dev install is done, and now we have a bunch of pip libraries. So let's install those. And then also you want to add the path to your ConceptGraphs Conda environment as an environment variable in your system. So that, if you don't know what that is, that's probably very confusing what I just said. So going to open another terminal to kind of just get into that a little bit. So, okay. When you Conda activate your environment, I guess it's concept graph. Okay. If you just do which Python as a command, you'll get the path to the current Python executable, which will be inside your Conda environment. So this is how you can find out where your Conda environment is. And you want to add that to your bash RC file. You want to add this export statement to your bash RC file. Sorry, I've done this so many times. It's like, and that way it'll set this CUDA home environment variable. So that way CUDA knows to find the CUDA install from your Conda environment as opposed to your base CUDA install. If all that sounds super confusing and you don't know what that is, just don't worry about it and do what I'm saying. It's just boilerplate code stuff. Okay, so I'm going to do that now. So I have a setup for my bash RC file. So I'm going to add that folder. Where is it? Okay. So yeah, so here's my bash RC file. Oh, and I should select the Python interpreter as well. So I'll just do that. Great. Okay. This seems like the right Python interpreter. So, okay. So in your bash RC file, you'd go all the way down, and then you would just add that line. Like this. So such, and great. Okay, so to demonstrate what I'm talking about here, so I'm going to do echo CUDA home, and there's nothing. But then I'm going to add this to my bash RC file, and then I'm going to go here. I'm going to say source to load it again. And then we're going to do the same thing. Now that environment variable is set. And then if you open up a new terminal, so let's do that. Because you put it in your bash RC file, which is loaded every time you open up a new terminal, you can do echo. If this is super basic stuff that I'm going over, I apologize. I just want to make sure it's like as thorough as possible. So, okay, so now that's done. I'm going to minimize this. And yeah, okay, so our pip install is done as well. And the CUDA home is set. So for these two terminals, it's not because I haven't loaded the source file in them. Any new terminals, it'll work. So finally install ConceptGraphs. So go to wherever your ConceptGraphs is installed, clone it, which we already did, check out the Ali dev branch, and then pip install -e. So let's do that. Okay, so gonna have this open here next to our instructions. So I'm gonna, from now on, I'll use the VSCode terminal. So let's just check to make sure that our CUDA home is set properly. Yep, okay, that looks good. Also, I think this is a little too zoomed in, frankly. I'm gonna go back. That seems a bit better. Right. Okay, so I'm already where ConceptGraphs is installed on my machine. So I've CD'd here because of VSCode. It does that for you. I'm going to git checkout alidev. You can see it says main. Well, your terminal might not, but you can do git status to check your branch, and we're on main, and we want to be on alidev. So you can either do git checkout alidev, or you can use VSCode to change the branch. So okay. Yeah, you can see it says alidev. So I wonder if I can remove this folder from my workspace so it's less confusing. Great. So yeah, now we need to install this into our Conda environment as an install this GitHub repo as a package into our Conda environment. So you can do that by doing pip install -e, and then dot means current directory. So I'm in the correct directory. I'm on the alidev branch. Great. That should work. Great. Okay, so we have our code set up. That wasn't too bad. I think it used to be much, much worse, and it's taken a lot of refactoring to get here. Okay, so let's start with the replica dataset. So we're going to go down to usage, and we're going to start with just the rerun realtime mapping.py. This script does everything all in one script. So let's go open that up. Slam rerun realtime mapping. My OCD is being bothered by the fact that this is being cut off, but alas, I don't think there's much I can do. This is still a bit too zoomed in, so I think it might be time to open this up in a full window. Okay, so this is what that script looks like. It's, I think, around 600-ish lines of code, and it looks a bit intimidating, but it really isn't. I'll go through the script in a moment, but let's go back to the README and kind of work our way through it. So let me just make sure I haven't missed anything else. We did this. After we've changed the configuration values, we can then just run the script as such. But first, we need to set up our config. You know what? Actually, to demonstrate what happens when you have not set up your config, I'm just going to try running it, and I actually don't know what will happen. So, and you know what? I'll open up the README file here as well, so we can look at it. Okay. Right. Okay. Right. So I'm in the right folder to run this command, and I'm just going to do Python, and then the path to the script. So we'll see what happens. That's really odd. I didn't expect this error. That should definitely be an indented block. I wonder why it isn't. And this is 3 weeks ago, so there's no way this should have run. Odd. But I wonder if it'll still happen somehow. Okay, let's just indent it. That's really odd, though. And then try again. So this, we're going to get other errors because ConceptGraphs does not know where anything is. So yeah, this is more like it. So no such file, because this is the file on my computer where I develop ConceptGraphs, but this won't be the same one on your computer. It's trying to find your ConceptGraphs doesn't know where your data set is, where you've installed the code on your computer, or anything like that. So you're going to get some or the other error. And this is the rerun viewer that launched, which we use for visualization. So, okay, let's close that. Okay, so, right, this is what it looks like when you run the code. And we need to set some values in our configuration files before we can use ConceptGraphs. So let's go back to the README and see what's happening. We use Hydra to manage the configuration files. It's a super helpful tool and library that helps you manage your configuration files. Okay, let's take a look at the configuration file for the script we're trying to run, which is rerun real-time mapping.py. So in the ConceptGraphs folder, you're going to have a folder called Hydra Configs, where you're going to have a bunch of config files, and we care about the rerun real-time mapping.yaml file. And it has a bunch of stuff going on. And you can see that it loads a whole bunch of other config files. So base is this config file over here, and base mapping is this config file over here. So what's happening is that this is using Hydra's functionality of composing config files. So let's say you have a logging setup and you want that to apply to all your config files. So you can store that setting, in its own file, where I just have verbose equals true. And then all your other files where you want that particular logging setting, you can load that file as using the syntax where you say defaults and then you load it. And the files are loaded in order. So if you have the same setting and you changed it in base mapping and say classes, then the value in classes will overwrite the value in base mapping. And then this self keyword over here means that everything in here is going to be loaded last. So everything in here will overwrite the default settings that you loaded up. So as you're experimenting, you can just dump all your settings in this file. And when ConceptGraphs makes a map, it'll also save a JSON file with all of your settings, so you know what settings you like, what data set, and what other settings you used to make that map. Okay, so what do we have to change? Well, our error before was telling us that record 3D scans, that's not was not found. So over here, these are the two dataset config files. So I'm going to change that to Replica. And just for illustration to see kind of how the error message progresses, I'm going to run this again to show you what the error is. So now there's no such file or directory. It's the same error, but it's for our Replica file. Okay, great. That's progress. So problem is that config.datasetConfig is not found. So that is going to be in one of the dataset config files. So let's go ahead and take a look at replica.yaml. It's taking wherever the repository root is and adding the path to ConceptGraph dataset data configs replica YAML to there. So if we go to dataset data configs and replica YAML, we have this file and it's in the right place, but we haven't set our root repository, like a repository root folder. So that's the what you want to edit. that is being loaded up from base paths. So we can take a look at base paths. And here we have the two main things that you want to edit. First is your repository root, which should be your ConceptGraphs directory. So we'll go up one. So we're in our ConceptGraphs install directory. And I'm going to just do print working directory. And here we have that path. And so we can edit this. Great. And over here, so now again, I really want to show kind of a bit of the debugging aspect of things. So I'm just going to keep running it every time we make a change so we can see how the error message changes. So, okay. Now the no file directory is the trajectory.txt. And that's because our data root is not set correctly. So you could have easily guessed that. So we want to find out where our dataset root is. So we're going to take a look at where we saved Replica. So Replica is over here. And you can see that in the Replica YAML file, it's wherever your data root is and then new Replica. So we can change this to just be Replica. And our dataset root is going to be this folder, my local data. So we can do print working directory to see where that is and copy it and paste it. And that's why I called it my local data, because if I had just called it new local data or something else that I already had, this might have worked, but it wouldn't have worked if you had not had that name already. So, okay. Now, this should be the my local data, and Replica should work fine. So let's try that again. Okay, great. So here, the models that we use for object detection and mask to compute the masks for the detected object, those are downloading. And in the interest of time, instead of using the large SAM model, I'm going to use the MobileSAM model in real-time mapping. So I guess this might be a good time to kind of go through the script. These are just the import statements. And then there's the main function, which has a decorator around it for Hydra that tells it what config file to use. So here is the path to the configuration files, and then which specific configuration file to use, which is the one we've been, well, not the one we've been editing, but the one we will edit soon. And there's just a bunch of setup going on. We're initializing the dataset, just initializing stuff like folders where we're going to output things and so on. And now if we're running detections, where you have the option to run detections or use detections that you've saved to disk already. Over here, we can change the model being used. So I'm going to say SAM predictor equals SAM MobileSAM .pt, which is a much smaller model that runs faster as well. Oh yeah, the OpenAI stuff for the edges. So okay, let's ignore that for now, and let's run this again with MobileSAM, and you'll see that it'll not download the other models that we've already downloaded, but will download MobileSAM, or did it? Oh, right, because it tried to reuse the detections from before. So I'm just going to change force detections to true, and also just specify a new output folder in our config file. So this will force it to do the detections again. And we're going to run real-time mapping. And yeah, it downloaded MobileSAM, the model. And I think it's going to get a similar error to before. Right, the OpenAI API key. So you have to set that yourself. Again, this is something that goes in your bash RC file. You want to make it an environment variable. This is to use GPT-4 vision as the detection model. So we actually don't want to do that at the moment. So I'm going to just comment this line out. When the edges are being made, I'm just going to say make edges is going to be false. And then OpenAI client is going to be none. We'll see if that works. Okay, so this is running. So I'm going to close this again because I closed the Rerun Visualizer. So I'm going to make sure we're doing a new experiment again. And run real-time mapping. So I guess looking at the Git repo is a good place to see what are the changes we've made so far. We've changed the base paths. This is probably the most important one. In Replica, we've changed the replica file. Oh, and in the meantime, our map is being built. So this is what the map looks like, and these are the input images that are being processed. And you can edit this as you'd like. You can see the camera frustum here. And then for objects, you can see their segmentation color or their instance color, or just their RGB color. Oh, I should zoom in as well. That should be big enough, it looks like. And over here we have a bunch of different labels. So we can turn both of them off to just have the bounding boxes. We can turn the bounding boxes off as well. I like to have the names of the objects be here. So this is the map that's being built as we're processing the data right now. It's fully incremental, and you can stop this and use the map from here. Like we can stop this at any point and only use the map that's been processed so far. So I'm going to demonstrate how to do that in a second after I've gone over the config file changes that we've made. So in the replica, we just had to change this path. And then in rerun real-time mapping, we said we want to use the replica dataset. And then we've changed force detections to true. And we've made we've changed the output folder for our experiment. And that's basically it. That's the gist of it. Over here, we're saying we want to use MobileSAM. And over here, there was that strange indent bug. But okay, say you have your map being built and you want to just use the map you've built so far and you want to stop here. So we can see that we've kind of got this painting done, and you can move, of course, the time scrubber, I guess that's what it's called, and see what's been built so far. And let's say we want to stop here. So this is super janky at the moment, but it was the least janky way I could have done this at the time. I'll probably make this cleaner in the future. What you do is in your Hydra config file, you find the early exit JSON file, and you change false to true, and you save it. And then the code will check at every iteration of the loop. It will check this file to see if it's the final frame. Sorry, if exit early was true, and if it is, then it'll exit on the next frame. And the code will prompt you if you want to save your rerun visualization so far, which you can do that if you'd like. So just to demonstrate how that works, I'll do that as well. So I'm going to copy this path, which is the suggested save path. And I would automate this, but to my knowledge, Rerun does not support that yet. It does not support piping the rerun logs to a place on disk and a running visualizer at the same time. Otherwise, I would do that. So, but that just means that you, after piping it to here, you just want to also then save it to disk. So I'm just going to put this in the path entry and then click save. And so this is going to write the file to disk. And it takes a little bit of time. Sometimes you can run out of RAM easily while doing this. So I recommend using something like System Monitor to monitor your RAM. So let's see what the RAM usage looks like at the moment. It's around half of my RAM is being used. So it is quite, because I have Rerun open still. So that's what that looks like. And you'll see the moment I close Rerun, the RAM will go down a little bit. Or maybe it'll happen. Oh yeah, it did. And then it'll go down a lot when I close this terminal as well. So then we have the press enter to continue prompt before we got some rerun logs here. So we press enter, and it'll also save the map. And then it'll make a symbolic link to the saved map so that you can visualize the map immediately afterwards. I'll explain more about that in a moment. But yeah, so the map, it has been saved and like zipped and saved to this path over here. And the edges are saved here as well. And now a symbolic link, and if you don't know what that means, it's just a shortcut. A symbolic link has been created from latest PCD save, which is a folder, a file in your ConceptGraphs root folder that points to the map that was just made, so that when you want to visualize the map to do queries, you can just always use latest PCD save as the path. And it'll always use the map that was just made. So I'll demonstrate what that means. So let's go back to the README. So we've set up our configuration. We've made a map, a partial map from Replica Room 0. And now we want to, so we've done all this stuff, and we can explore the experiment folder, the output folder for the experiment. So let's do that. I'm going to make a new window where I'm going to go to my local data, replica. So the output is stored in the dataset folder so that you can easily keep track of like what experiment it was. So in Run 0 experiments, these are the folders that for the experiments that we've run so far. And you can see that this one is the most recent, has the most items, because this is the only one that we ran to completion using the early exit file. So there's the detections folder where you have the literal detections that were saved. So ConceptGraphs saves a bunch of classes, the class IDs, the confidences, the edges. This is going to be empty for now because we're saying edges equals false. The crops of the images for each object, the clip features for those images, the labels, masks, the clip features of the text label, and the bounding boxes. So, and it doesn't take up much space other than the image crops, which take up the bulk of the space here. So that's what's in the detections folder for each frame that we processed. And you can see that because we have stride equals 10 here, we're going through every 10 frames. I hope this is visible and that I don't need to zoom in more. Well, I hope it's visible. Otherwise, it just says frame 0, 10, 20, 30, so on. And then in the visualization folder, this is super helpful. It has all of an image where we've plotted all the detections that were made. Also on the depth, and then this is the depth image, and it does this for every single frame. So you can turn the saving off in the code if you don't want this to be saved, but it honestly doesn't take up all that much space. So that's the detections that were saved, and the map is saved in the mapping folder. You'll see that these are the folder names are the labels that we picked in our config file for Rerun real-time mapping. So inside the mapping folder, you'll have the parameters that okay, I can't zoom into that, so I'm going to open it up in VSCode. These are the parameters that we specified in the Rerun real-time mapping YAML file, but also any other params that were loaded. They're all saved here, so you can know what settings you ran that particular map with. And here is the map that was built. It's saved as a zip pickle file. And over here, you have the RRD file, which is the rerun log that we saved, which is much larger than the rest because it has like all of the images and the point clouds for every single time step. So that those files are sizable. And now we want to do some queries because that's what ConceptGraphs is all about. It's about being able to find objects through natural language in your scene, precisely in 3D. So we want to run some queries on our saved map. So let's do that. Because normally you'd want to specify, okay, I want to do querying for this particular map, but because of the symbolic link that's being created every time you run any of the scripts, you can just run the visualization script directly. So running the visualization script, we go to ConceptGraphs again, and then here's the command that we're going to copy and paste. Oops. That seems not right. I feel like some weird keyboard shortcut thing happened there. But okay, back to visualizing the, or visualizing and querying the map. So this is our code here. We're going to paste it and press enter. And this will load up our map so we can query it for objects. So it takes a few seconds, and here we go. We have our model. You can press B on your keyboard to remove the background object. So that's the floor and the walls. So it's easier to see. This is the map we built. Because the last final frame is processed, when the early exit trigger happens, we've got some more of the map than was in the rerun visualization. But anyway, now we can start querying this map. So I'm going to say always on top for this window. And if we press F, we can start querying the map. So I'm going to zoom in here so it's easy to see what's going on. So now I'm going to press F, and now we have a prompt, enter your query in the terminal. So I'm going to say cabinet for the cabinet. And now the map has been colored. We've gotten the information about the object with the highest similarity, and you can see that it's the cabinet. It has the label and table, but because we use clip to do the querying, the text label doesn't matter. It's going to be roughly accurate to how good YOLO is at doing these detections, but the searches through clip features will work much better. So, okay, this is how you do a search. So I'm going to try another query. So I'm going to say door. And there we go. Just to show off some of the more interesting queries you can do, you can say comfy place to sit, and the couches and chairs will have highest similarity. So you can specify the objects however you want in natural language, and the concept graphs can handle that really well. Okay, so that is basically it. So in this video so far, we've installed and set up the Conda environment for concept graphs, following the instructions here. We've downloaded the dataset. We edited our configuration files, and we then built a map for room 0 for Replica. So let's just go over what we've changed by looking at our Git status in VSCode. So these are just the models that we downloaded. This is the file that assigns the colors to the classes, latest BCD save. And now we can take a look at what are the changes we've made in the in our config files. So we had to change the so we had in our base paths YAML, we had to change the repo root and the data root folder to be where we installed concept graphs and where we placed our dataset. In our replica file, this you shouldn't have to do because I'm going to commit and push this change. But you might have to change where you've saved your replica dataset, and we set a new location for our experiment by editing the label experiment suffix and detections experiment suffix, and whether or not we were using replica or record 3D. And we changed force detections to true. But if you were to specify a new experiment folder where there are no existing detections, it would run the detections anyway. But force detections forces it to do that. So to show you what I mean, we're going to change force detections to false, and then not change the detections experiment suffix. So we're going to keep it at 12, but we're going to change the experiment suffix to be 13. And we're going to run the code again. So you'll see that the output, I guess you can go back in the video, said running detections a bunch of times. And I'm going to make verbose equals false, actually, so that it doesn't print a lot of stuff. So Hydra verbose equals false. And yeah, this is, so whenever you want to change anything, you just edit the corresponding config file. So we're going to run real-time mapping again. And you'll see that this time it'll say not running detections. So it's going to reuse the detections from before. As a result, it's going to run much faster. So once you run detections for a particular data set and you're happy with those detections, you don't have to redo those detections again. You can just use the ones that you already had. Yeah, that saves you a bunch of time and effort when you're making a map. And obviously, you can move the camera around as the map is being built. You can also take a look at specific objects and open them in new windows. So if you do right-click, add to new space view 3D on the rerun page, let's make this a tab for this file here. This is the lamp, and you can kind of scroll through time and see how it was changing. And at a certain point, it didn't exist and it was made. Actually, I think the painting might be interesting to do this with. So let's do that. Let's take a look at the painting, which is being detected as poster. So here we have it, and we can see that it didn't exist before, and then yeah, it kind of comes into view as the map is being built. So the visualization tooling for ConceptGraphs is really, really good, in my opinion. All the credit, well, the overwhelming majority of the credit for this goes to the team at Rerun. I highly, highly recommend you use it for all your 3D data visualization projects. And you can see that you can interact with the map, you can isolate objects. There's different labels that you can use. So over here, if I turn this on, it tells me how many times each object has been detected, and so on. So yeah, it really helps you kind of see how the map is being built and what your settings are doing because of the visualization tooling that we have. Okay. Right. Because we didn't process the whole data set, and we only had detections for 73 frames last time, our code is crashing or has crashed. This is something that I'll probably fix in the future. But for now, you can just add an exit statement that checks the frame and stops so that the code doesn't crash. Or just run one detections pipeline overnight and then reuse those detections. It's up to you. Okay. What do I still have left to talk about? So we've made a map. We've reused the detections from a map that we made beforehand. We did some visualization and some searching. I think that is about it. What else? Okay, I do want to, so I'll pause here and then I'll probably add some other stuff if I have missed something. Okay, hey, so I'm back. And that is kind of everything I wanted to cover for making a map from the Replica dataset. I just also want to do that for making a map using an iPhone. So I'm just going to go through that part now. And I'll put that in the README later. But if you want to use an iPhone as a sensor for ConceptGraphs, you can do that using the Record 3D app. So let me go on Google and just Google Record 3D. So this is an app for iPhones. If you have an iPhone with a LiDAR sensor, you can download this app. You'll need the pro version. So it's like something like $5 to $10. And that'll allow you to export the scans that you do as a, I should move this. I'm going to be more mindful of the fact that my face is blocking like this area. Anyway, you can, make 3D scans like RGB plus depth plus poses, data sets to use with ConceptGraphs of the record of your own environments. So I'm going to now download one of these. Okay, so I have my local data folder here, and I'm going to make a new folder where it doesn't say replica, it says record 3D. And over here, I'm going to paste the R3D file. So I'm going to trust that you can look up how to make a 3D scan using the Record 3D app and get an R3D file that you'll then have to figure out how to get from your iPhone to your computer. I just use Google Drive to upload it there. And if it's not clear, you can leave a comment below and I'll make a video about how to do that or answer your question. We want to now so this is the Record 3D file extension that you can, that Record 3D exports to. So you should be able to get this out of that app for any of the scans that you do. Then we can extract that here and take a look inside. So there's some metadata, a folder that says RGB-D, and you have the JPEG and depth for each folder. So this is just a scan I did of an aisle in a convenience store. I'm going to rename this to CO. So I'm going to say my CO store. What we're going to do now to process this in ConceptGraphs is we're going to have to first pre-process the data set that we've just created. So we want to go to the scripts folder where we'll have a So it's in the dataset folder. Yeah, dataset preprocess R3D file. So let's take a look at this file now. We want to change the path in here to where our dataset is, like the folder we extracted from the R3D file. And this will basically process it and make it like the kind of datasets that ConceptGraphs is compatible with. So we have our folder over here, and you want to basically take the parent folder of whatever metadata is. So you can go to properties and kind of see what the path is, like that, and then update it in here. And then you can run the script, and it'll make a new folder where the processed output dataset file folder will be. So it'll make a new folder in the same folder that your current dataset is in. So let's take a look over here. Okay. So I want to do Python dataset preprocess r3d file.py. Oh, okay. Looks like we're missing a dependency. So pip install lib l fsc. Oh, okay. I wonder, it probably goes by a different name. So let's just look it up. Pi lib zfe. So, okay. Should add that to the README file. So can do that super quickly. Great. All right. Sweet. Back to this file. Let's try running it again. Oh, wrong command. No moduling. Install PNG. I wonder if it's PyPNG. Yep. Great. Okay, so now this is doing the processing. So I'm going to add PyPNG to the README as well. And yeah, this takes a while. Well, not a while, but the higher resolution your images and so on, the longer it'll take. So I'm probably going to use the magic of video editing again to deal with this. We've got our dataset pre-processed. And so now let's go take a look at it. So what this script will do is it'll make a new folder called the same thing you had earlier with pre-processed appended to it. And now this looks more like a ConceptGraphs dataset. So we've got the RGB images, we've got the poses, and the depth maps for this dataset. Now, if we want to use it, we just have to go back to our rerun real-time mapping YAML file, change replica to record 3D, go to our record 3D YAML file, and change this. So my data set is in my data root folder, and instead of calling it record 3D scans, I've called it record 3D. So I'm going to change that. Oops. Okay, and then I have, instead of CO store process, I've called mine my CO store process. So I'm going to do that as well. My CO store process. And the rest of this should be fine. So now let's try running rerun real-time mapping, but with the iPhone dataset instead, and see if it works. So okay, so from the README file, the command should work. Okay. I think it's Python slam. Oh, I should fix that in the README then. So, okay. But before I do that, we've got an error. There's no such file or directory. Data config.yaml. So let's see if that's an issue. Oh, because it's not processed but pre-processed. So I have that wrong in the default. It's pre-processed. There we go. That was just a typo. So okay. Hopefully this runs this time. Let's see. Oh, okay. So I think there's usually some problem when I already have a rerun open. So I'm going to exit out of this. And try that again with my rerun window closed. So just to be safe, I'm also just going to make a new output folder name so that it's not going to overwrite or mess with something that was saved before. And okay, looks like the rerun window is open now. We're running detections. So yeah, loading up the models is like the main friction when it comes to making maps. So okay, so here we are, and the map is being built, and this is from the convenience store that I recorded with my iPhone. So I'm going to exit early again, so we can just then do queries on it. Great. So yeah, early exit signal detected, and it's going to prompt me to save, which I am going to, just in case I might use it in the video. So we're going to save the recording. And then we can close, rerun, and press enter here, and it'll save the map. And this is why the latest PCD save thing is helpful. So it's updated the symbolic link, so we can again go back to the README and find the command. Oh, right. Okay, so there's something weird happening because I'm pressing Control-Shift-V instead of Control-V. Okay. So now I'm running the visualization and querying script again, and it's loading clip. And we're going to see the convenience store map. So it's very much incomplete because I stopped the scan very early. But so, for example, we can see there's a packet of beef jerky here. So let's try doing a search. So let's say beef jerky. And there you go. So the whole shelf, because it had a bunch of beef jerky on it, is being highlighted. But yeah, so, and again, to show off what the fuzzy queries are like, so I can say Jack Links, which is the brand name. And we still get a much stronger highlight this time because we're referencing the packet by brand name. Yeah, now you can start querying something you scanned with your iPhone. Great. There is one last thing I want to show off. Not only can you record a scan with your iPhone and then make it a ConceptGraphs dataset, but you can also stream data from your iPhone directly as you're doing the scan. And I think this makes it very easy to have a really fast iteration cycle for doing your recordings. So you can make your maps quickly, see what's wrong immediately if there's something wrong, and iterate. So for that, we're going to use a different script, which is almost identical to the rerun real-time mapping. It just, instead of using a data set, it streams instead. So I'm actually going to just compare these two files so you can kind of see what I'm talking about. I think I might have to zoom out for this to work. Yep. So we have the streaming file on the left and the normal file on the right. And over here, on the normal file, there's a data set. In the streaming file, there isn't one. And that's it. There's just some minor changes about how you're using the stream data instead of the data set. And that's really it. So let's try running this file this time. So I'm going to change this to R3D stream rerun real-time mapping.py. And for this, you're going to have to use an iPhone at the same time, of course, because that's where you're streaming from. And I don't know if the camera is going to be able to see this, but that's what this looks like. And I'm just going to press the record. So now it's streaming and waiting for a process to connect to it, which hopefully will be this file. So no such file or directory. Okay, maybe I'm just spelling it wrong. Oh, right. Okay. Sorry. CD. I can't type with one hand as fast. ConceptGraphs. Oh, no module name record 3D. That makes sense. Pip install record 3D. Oh. Okay. So I think I guess it makes sense that this should be in the video. You'll have to install the record 3D Git repo. So should be here somewhere. Yep. Okay. So I'm going to open a new terminal, and I'm going to do go into my code and do git clone record 3D, and then cd into that folder. And notice that we're still in the concept graph Conda environment. So what we can do is likely following the instructions on the record 3D repo, Python setup.py install. Let's try that. Okay, looks like cmake must be installed. That makes sense. This is exactly why I wanted to make this video, because these are the kinds of things that you forget to put in the README. So cmake and then this guy. So let's do that first. And then cmake. So I wonder if there's an easier way to install cmake. Linux install cmake. So maybe sudo apt install cmake will just work. Let's try that. Okay, and now let's see if that will work. So we were wanting to do Python setup.py install and record 3D. So okay, it's building the library, and it should have now installed it in the ConceptGraphs virtual environment. So now we can go back and try the streaming real-time mapping.py and see if that works. Oh, not running detections. Right. So we want to specify a new folder because it tried to reuse the detections from before, which won't work. And then try that again. Oh, and I didn't have my rerun open at the time. So let's just change that again. Rerun is closed. Sweet. So to my left, I have a couch that should hopefully show up. So here is the rerun viewer. The models are being loaded. All right, the OpenAI API key. Oh, I guess I should demonstrate that too. So okay, I'm going to pause quickly. Okay, so I'm back, and I've opened up my bashrc file again, where I'm putting my OpenAI API key in there. So this is obviously not my OpenAI API key. I'm just showing for the video what this would look like. Okay. Right. So I've added my real OpenAI key to my bashrc file, and I'm going to now update the experiment output folder, and rerun is closed. Okay, cool. So we can run this again. And this time it should stream directly from the iPhone here. It'll take a second to load up everything, but it should start streaming once that's done. Oh, right. So here is the rerun viewer, and I'm going to move the phone. I'm just going to make it see my face. So there we go. And I should be showing up at some point. So this is the couch that's to my left. And the air conditioner. Let's turn off these labels. And yeah, so that's me showing up on the map, and the air conditioner behind me. And yeah, so I'm gonna exit early. And now I'm gonna put the phone down. Save the map. Close, rerun, press enter, save the map again, and then I'll demonstrate a query or two on that map. Cool. So to the README, where we have the visualization query. So oops. And this is going to load up the point cloud that we just saved, or the map we just saved from the stream. So this is a tiny chunk of my apartment. So that is my couch. I've got a backpack on it. It's probably hard to see, but this is the couch, and then that's the air conditioner, and so on. So let's try doing some queries. Always on top. So air conditioner. And there we go. So I wonder if my water bottle over here will work. So let's try that. So yep. Okay, so that works. Yeah, so when you're directly streaming the data set, the depth quality is lower because Record 3D does some post-processing. And you want to be sure you're not shaking the camera a whole bunch. All of that affects the final scan that you get. I guess I should also talk about edges for a moment, because so this is something where checking things comes in handy. So if we take a look at the replica folder and see our experiments and see the latest one, and take a look at the parameters, there should be one called make edges. So I'm just going to search for it. Make edges. Okay, make edges is true. So let's go and change that back because we hard-coded it to false and none. So we can just revert this change, and then go get the OpenAI client back. And we can still have that be MobileSAM. And now the map is going to include edges, which are relationships between objects. So let's try doing a replica scan again. And I'll demonstrate how to use the VSCode Debugger, which is super helpful. I've made and committed a debug config already. So it's in the root directory of ConceptGraphs, where you have the default VS Code current file and current file with arguments, debug configs, but then also you have the detections, real-time mapping, the streaming, and the visualizing and querying the map. So I find that this is an easier way to run things. So you can go to the debugger in VS Code and then select real-time mapping and click the play button. And this will launch the exact same code, but in the debugger. So this is equivalent to running this command from the README. So because we're running now from a different folder location, so this is running from the workspace folder as root, it will re-download the models that were saved because we're running the code from a separate directory, so the cache isn't being detected. I think so for things like this, it's super helpful if you want to contribute a simple fix for that yourself, where you just check the folder location for the cache for the Ultralytics models and you fix it accordingly. I just basically run out of time in the day when I'm working on this, so some convenience functions don't get fixed. So, okay, so now the map is being built, but soon enough we should see edges. It takes a lot longer when you run with edges, which is why that's not enabled for streaming from the iPhone, because it kind of defeats the purpose. When you're streaming stuff, you want it to be fast. And the getting the reply from OpenAI for GPT-4V, processing the image, asking about the object relationships is by far the time bottleneck. So the edges are being printed to the terminal, and here we see the edges. So the thing that's being detected is a coffee maker on top of the cabinet here, and then the pillow on top of sofa chair, and so on. So I can just kind of make it a little more readable. So yeah, we've got a few things on top of each other. So this is kind of how the edges work, and they help with the having a scene graph, like a object map with more detail. Okay, I think that is roughly it. So I'm going to stop again. I'm going to go to early exit and just say true. I'm going to save. And okay, file saved. I can close rerun. I can press enter here, and it will save the map. Now you also have your edges between objects that identify the physical object relationships. I think that's about it for this video. I'm going to try and think about if I'm missing anything. No, I don't think so. Okay, so let's take a look at our Git folder and see what's going on here. So this is just something we want to add to the git ignore. It should already be in the git ignore folder. So outputs. So we have a few copies of the models. We made some changes to the README file because there were some missing packages that I'll commit to the repo. And yeah, we had to change our base paths. We had to change where we put our Record 3D and Replica datasets, and then some settings in the real-time mapping.yaml file. And we changed the model here in the rerun real-time mapping.py. So I think before I drop off the video, I should just go over kind of what ConceptGraphs is doing and go over this main script here. So, okay, so you have if name equals mains, then main, and then you go back up to the main folder. You have the Hydra decorator around it that tells you what the config file to use is, and then that becomes CFG in the main loop. We're setting up the rerun module and the weights and biases module. I've just made a wrapper so that if you don't have that installed, the code still runs fine. We initialize a dataset using the YAML files from our Hydra configs folder, initializing the objects, map edges, the output paths, object classes, and then if we're doing detections, then the models that we're going to be using to do those detections. We save the config file at this point, so that's what creates this JSON file. And then we loop over every frame that we're processing in the dataset, and we extract some things out of the dataset, like the color image, depth image, and so on. And then if we're running the detections, we run the detections. We get the bounding boxes from YOLO. After that, we get the masks from SAM, and then we get the edges from GPT-4V. We get the clip features from clip, and we save the results if they're being saved. So if the save detections is true, then we write those detections to disk. And then after that, we get the pose out of the data set. We log a bunch of the detections that we've made so far on rerun. That's what kind of these functions over here do. And after that, we're just doing some resizing, filtering. And then using the depth, we project those to 3D. And then we also just do some processing of the point clouds. So over here, this takes in the images and our detections, the masks, bounding boxes, and so on, and gets the individual point clouds for the objects. And then we just denoise them and downsample them. And then after that, we, if it's the first frame, we just add those objects to our objects list. Or if it's not the first frame, that means any of these objects could be repeat detections. So we compute the similarity, and then we merge the objects. So if the similarity for each newly detected object is higher than a certain threshold, we'll merge them into the object with which it had really high similarity. So then we also process the edges, because if objects are being merged, the edge needs to be adjusted. And then there's a bunch of post-processing, so denoising, filtering, merging of the objects. Then we can log the bounding boxes and the edges to rerun. And then if we're rendering and saving stuff, we do that. We can also log stuff via weights and biases. And then after that, the loop's over, and we just save the point cloud or the map and the and anything else that needs saving. So that, in a nutshell, I know I went pretty fast, but is kind of how the code works. And I would really recommend using the debugger. So if you use the debugger, you can set breakpoints at various places in the code and kind of inspect things that are happening. So I'm just going to run the code again, wait for it to pause at this breakpoint, and then I'll just kind of show you what you can do. So here the code stopped at this line, and we can see like the value of all our variables over here. So the grounded observation is none, frame index is 0. So let's say you were curious what the color path is. So you can see color path in the debug console in VSCode. And then you can get color path dot parent. And then if you're really feeling ambitious, you can even change like the color path to be something else. So say string temp. And then if you check color path, it'll be called temp, and then this will probably break the code. So if I continue, yep. So yeah, that's the debugger. It's really super helpful in kind of figuring out what's going on. I recommend you use it. And yeah, you have these options to start with, but you can always make your own debug configs as well. So yeah, okay, I think I've covered installing and setting up ConceptGraphs, downloading a dataset, making a map of your dataset, then querying the map, and then also doing the same with an iPhone scan and streaming directly from your iPhone. Okay, I was just making sure I kind of had everything. I went over the early exit feature, and the pre-processing the record 3D files. Okay, I think that's it. So yeah, I hope this is helpful for getting started with the code for ConceptGraphs. If you have questions, you can make an issue on the GitHub, or you can leave a comment down below. I really love this project. I use ConceptGraph maps for my robotics research, and yeah, it's really, once you kind of get the hang of it, it's pretty fun to use. Okay, I think that's everything. Thank you for watching, and yeah, that's it for today.